Next, we'll start about the Opamp. Okay, I'll completely discuss about the Opamp this lecture. So, basically, what is Opamp? Opamp is an operational amp amplifier. Okay, so it's an operational amplifier. What is basically an operational amplifier? It works as an amplifier. Suppose I am giving you one example, like you are speaking something in a front of audience in a stage in mic, okay, and your voice, that audience, that is getting from the loud speaker. So your voice is same, right? But your voice, we are listening, that is a very high level. So basically your voice is acting like a signal, correct? Suppose you are speaking with a 20 decibel of voice, but in the output we are getting 1000 decibel of the voice. So how much is the gain? Gain is basically output divided by input. So output is 2000. Put only you just said 20 decibel. So gain is how much? 100 times. So basically your voice is increasing 100 times. Correct? With the help of, in between you have used amplify. So the same thing is done by the op-amp. It boosts up the same signal to a high level. It basically increase the magnitude. So in the op-amp, the symbol of the op-amp is will have two types of terminal. One is the positive terminal, another is the negative terminal. So positive one is connected like a non-inverting input, and negative one is connected with the inverting input, and this one is the output. We denote it by generally by V naught. Here we are providing the supply, that is plus V and minus. Okay. Now understand that what is non-inverting input. If I'll provide the voltage to the positive terminal, not towards the negative terminal, then in that case non-inverting means, suppose we are giving the voltage with this supply, and in the output voltage will have the same phase. Same phase means first here you can see it's a positive cycle, then negative cycle. Then in the same phase, in the output will get positive cycle and negative cycle. But what is the change? There is change in the amplitude. There is a the magnitude. It means the voltage is converted connected to the non-inverting. Non-inverting means phase is same. Okay, phase remains same. But what happen if I'll provide input to the inverting? If I'll connect voltage to the negative terminal and the positive one is grounded, then in that case again input, suppose we have given like this, and output will be the change in phase. Here we are giving positive supply, negative supply, but in the output we are getting first the negative supply and then the positive supply. Okay, so basically it's the, in this case the phase will change. Phase will change. Okay, so that is the inverting. Okay, this one is the op-amp symbol. So one by one we'll learn will have different types of op-amp that we need to study the derivation as well as the numerical. Okay. So how many types are the op-amp will have which comes in the exam? One is the inverting amplifier, another one is the non-inverting amplifier, another one is the summing amplifier, another one is the subtracting amplifier, then we'll have integrator, and then we'll have differentiator. Okay, so one by one we'll learn all the derivation of all this because that will come in midterm as well as in end term. So first one we'll learn about the inverting amplifier. As its name suggests, inverting amplifier, it means voltage is connected to the negative terminal or the positive terminal. Tell me. In the inverting terminal, tell me, voltage must be connected with the positive terminal or the negative terminal, according to you. Hmm. Voltage is connected with the negative terminal. So here, voltage, suppose I am considering it as a V in is connected, okay, and it is connected with the resistance R1, and it is connected with the feedback resistance, that is RF. Feedback resistance is the resistance which is connected output with the input. Got it? So every time we'll connect to the feedback resistance with the negative terminal only, whether it's an inverting amplifier or a non-inverting amplifier. Feedback must be connected with the negative terminal only. Now we don't need to connect anything with the positive terminal, so it would be grounded. Output is denoted by V out. Correct? Now in this we need to calculate the value, the formula for the V out which we used in the numerical. So for that we have to apply KCL. Remember the KCL which we have studied in again BT. KCL is the Kirchhoff current law. Like suppose here the current flowing here is I1 and here the current flowing is I2. Okay, this is a node, right? Because here the current divides. So some of the things which you should know about the op-amp, that the voltage at the positive terminal would always be equal to the voltage at the negative terminal. That is according to the concept of virtual ground. No, virtual ground. You don't need to learn the derivation of the virtual ground, but you should write it down in your exam that voltage at the positive terminal is equal to the voltage at the negative terminal by virtual ground. Okay. So now you know that the voltage at the positive terminal is grounded, and at the ground the potential is always equal to 0, right? So V positive is equal to 0. So at this point the voltage is equal to 0, and at this point also the voltage is also 0. Correct? Okay. So that means no current is entering into the negative terminal. Hmm? N- It is not 0 at the feedback. See, I told you voltage across the positive terminal is equal to the voltage across the negative terminal, right? So voltage at the positive terminal is how much? 0. The voltage at the negative terminal is also 0. Okay? Hmm? So in this case, now we need to apply KCL. What is the KCL? That is sum of the incoming current is equal to the sum of outgoing current. So let us consider this node as A. How much current is entering into the node A? Tell me. Hmm. This one is node A. I1 is entering and I2 is leaving, right? Now you need to convert it in terms of V by R. I1 is moving from V in to 0 or 0 to V in. Check out the direction. I1 is moving from V in to 0 or 0 to V in. So I1 is how much? In minus 0 divided by the resistance in its path, that is R1. Correct? Now similarly convert the value of I2 in terms of V by R and then let me know. So it would be 0 minus V out divided by RF. Correct? Now from here we need the value of V out only. So we need to solve it and then tell me what would be the value of V out. We got it after solving it, minus V in multiplied by RF divided by R1. So this is the formula which we need to remember for the case of inverting amplifier. Got it? Sometimes in the question they can ask you the gain also. As I told you, gain is what? Output divided by input. And in this op-amp, gain is represented by A, output voltage divided by input voltage. So from this expression we can get it that V out by V in is how much? That would be minus RF by R1. Minus sign is also there. Minus RF by R1. What does this minus sign indicates? That it's an inverting amplifier. Inverting amplifier means there is a change in phase. Correct? There is a change in phase. So that's why here we got it as negative V in into RF by R1, which shows there is a change in. Understood? Next we'll learn about the non-inverting amplifier. So non-inverting amplifier, as its name suggests, tell me, amplifier must be connected to the positive terminal or to the negative terminal. Sorry, voltage is connected with the negative terminal or to the positive terminal. Right. So I am connecting the voltage, the positive terminal, that is V in. And as I told you, feedback is always connected with the negative terminal, that is RF. This one is R1 and another one is grounded. Another terminal of voltage is also grounded. This is represented by V out. Okay. Again, we have to apply KCL in this. Let us consider the current flowing in RF would be I2, current flowing in R1 would be I1. So this is a node A. Now again we have to calculate for V out. Calculate it. We have to apply KCL at node A. Tell me the current entering into the node A is equal to the current leaving the node A. Which current is entering and which current is leaving? I1, I1. I1 is leaving and I2 is entering. So now again we need to convert I1 and I2 in terms of V by R. First of all, tell me what would be the value of I2 in terms of V by R. I2 is moving from V out to VA or VA to V out. V out to VA, so it would be V out minus VA by RF. Similarly, tell me I1 is moving from like the 0 because at ground no potential is 0. I1 is moving from VA to 0 or 0 to VA. So it would be VA minus 0 divided by R1, right? As you know, at this point and at this point, the potential is same or different. If there is a plain wire, then the potential across all the wire is same, right? This is how much? V negative, the voltage at the negative terminal. Can we denote it like this? So we already know one thing, that V negative must be equal to V positive according to the concept of virtual ground, correct? So if V negative is equal to V positive, as you know, this is V positive. So now tell me, V positive and Vn, they are the same voltage or at the different voltage? V positive and V in, they are the same voltage or the different voltage? So it's the same. Yeah, it's the same because there is no element connected between them. V negative and Va is also the same. So can we say that all V negative is equal to V positive is equal to V in, and V negative is equal to Va? All the voltages are same? Yes or no? So instead of Va, we have to calculate in terms of V in. So we'll write down V in minus 0 divided by R1, V out minus V in divided by RF. Correct? Now from here, calculate the value of V out in terms of V in and then tell me the answer. So after solving it, we'll get the V out value as this one, correct? 1 plus RF divided by R1. As you can see that we don't get any negative sign over here, right? So that means the phase is not change. Phase will remain same. That's why it is an non-inverting amplifier. If you want to draw the waveform, you can draw the waveform also. This is the input waveform, and output waveform. There is a change in magnitude, but no change in the phase. Note down this one. Noted. Next. Hmm. The amplitude increases. The cycle. Sorry. The cycle is also same. Like it vary from 0 to 1. It also vary from 0 to 1. By बनाने में वैसे ठीक है, it's same. Next one is the voltage pullover. In the voltage pullover, we have no feedback resistance and no input resistance. Okay, hello. Okay, I was telling you related to the voltage pullover. So in this case, output is again represented by V out. Negative is connected with the feedback but without resistance. In this we don't connect any feedback. Here the voltage is given V in. Okay. So in this case it's a special case of non-inverting amplifier, as the voltage is connected with the positive terminal. The feedback resistance is equal to 0, and in this case voltage gain is unity. Why it's unity? Because as you know, gain is how much? Output voltage divided by input voltage, that is equal to 1. Output voltage is equal to input voltage in this case. Okay. So what is the special about the voltage follower? They sometime they'll ask you in the um, MCQ based question that it has very high input resistance and very low output resistance. Okay. So you have to remember this, that voltage follower will have very high input resistance If we'll have very high input resistance, then current would be how much? Low, right? At the input side. And if we'll have low output resistance, means current is high at the output side. And that's what we want, that we want that current should will we give to the device should be very less, so that it will take less battery, right? And in the output we should need high amount of current. And mainly the voltage follower will used as a buffer for impedance matching. Okay, so you have to remember this term for MCQ based type question. Noted down. Next one is the most important, summing amplifier. That there is a 90% chance कि summing amplifier question you will get it in the exam, maybe in midterm or maybe in end term. Okay, so you can mark it as important also. In the summing amplifier, as its name suggests, it's added something, right? So another name of summing amplifier is adder also. Will have an op-amp. Again, positive terminal is grounded. Negative terminal is connected with the feedback, as I told you, RF. So in this we need to provide the two voltage. Okay. One, we can denote it voltage by VA. Another voltage we can denote it by VB, or we can take the third voltage as well, because we need to add the voltage, right? Voltage is connected with the resistance, that is RA. This is also connected with the resistance, that is RB. Okay. Hmm? So this is the output voltage. Again, we need to calculate output voltage. For that, we have to again apply KCL, Kirchhoff current law. Suppose here I1 is flowing. Hmm? So in this case, I1 current is flowing. In this case, I2 current flowing is there. And in this case, IF is flowing. Okay. So now we have to apply KCL at this particular node. Now tell me, apply KCL at node A is how much? Tell me the value. How much current is entering into the node A? The voltage, the node which is connected with the negative terminal will generally take that node. Okay. Hmm. So after solving it, get correct. V out is equal to minus, we'll take it common. Okay. So it would be VA into RF by RA plus VB into RF by R. Correct? So this is the main formula for the summing amplifier. It is connected to the negative terminal. As you can see, that voltage is connected with the negative terminal, right? So in this case, the output will get it in the negative. Like if suppose RF is equal to RA is equal to RB, then can you tell me the value for V naught, V out? That then V naught would be equal to how much? Then it would be equal to minus, we'll take it common, VA plus VB, right? So it's the summing amp. We'll add the two voltage. Got it? Okay. You noted down this one? Next amplifier is the difference amplifier. Difference amplifier is the subtractor. Okay. So in this we have to use superposition theorem. Remember the superposition theorem that you have studied in B. In this case, again feedback is connected with the negative terminal, and here resistance is there R2, and here we'll provide the voltage V2. Here also will here also the resistance is R3, here is R1. You have to learn this diagram basically. Okay, and here this is the voltage of R3 terminal is grounded. Huh? Yeah, for all of them separate. So this circuit is analyzed using superposition theorem. We have to consider only V1, then V2 is 0, then we need to calculate output voltage, right? Then again we'll need to consider V2, V1 would be 0, then we need to calculate the output voltage, and then we need to add the voltage. Okay, so let's redraw the diagram again. Suppose now we'll consider V1, okay? Then V2 would be removed. Removed means completely removed. So now in this case, output voltage we can denote it by V01 because we are considering V1 now, correct? We have to do it by this, we have to do this derivation by the superposition because in this we are giving two voltage, right? At the two different terminals. In the last case, we have given the two voltage, the negative same terminal. We can do it directly, but in this case we are providing two voltage at the different terminal. Okay, so that's why we need to do it. So we need to consider first the V1 voltage, then the output voltage. V01 is how much? Let us consider this point be Vx. Okay, so now tell me here the V1 is connected with the positive terminal or the negative terminal? Positive terminal. If V1 is connected with the positive terminal, then it would be a inverting amplifier or a non-inverting amplifier. It's a non-inverting amplifier, right? And tell me the output voltage formula for the non-inverting amplifier. What was the formula? V in multiplied by 1 plus Rf by R1, right? So this is the same case we need to apply it over here. Now V01 we need to calculate, right? V01 is how much? V in. Now we have applied the voltage across here is X, okay, multiplied by 1 plus Rf divided by, with the Rf, which resistance is connected? R2 or R1? With the feedback resistance, with the R2, so we'll take R2. Okay, done. Now we need to calculate the value for Vx. As you can see that Vx is the voltage across R3, right? So can we apply voltage division rule, calculate the value of Vx? Did you remember the voltage division rule for from BT? Okay, I'm telling you what was voltage division rule. Voltage division rule is applicable only in series circuit. Like suppose this is ohm, 4 ohm and 10. We need to calculate voltage across 4 ohm by using VDR. So the voltage across 4 ohm is how much? Total voltage is 10 multiplied by. In which branch we need to calculate voltage? That resistance 4 ohm divided by sum of resistance which are connected in series. That is 2 plus. So that would be the formula. Okay. Now similarly tell me if we want to calculate voltage across 2 ohm by using VDR, then what would be the value? Voltage across 2 ohm by using VDR. Hmm. So by applying voltage division rule, Vx will get it as voltage we have given V1 into, we need to calculate voltage across R3, so R3 divided by R1 plus R3, correct? So can we substitute the value of Vx over here? Then we'll get V01, right? So finally we got it as V01 is equal to V1 into R3 divided by R1 plus R3 into 1 plus Rf divided by R2. Okay, now we have taken V1, now we need to calculate it for V, right? Same steps we have to do. Now in your notebook read the diagram and then consider. Okay, as you can see that voltage V2 is connected with the negative terminal or the positive terminal. Now consider, remove V. So negative terminal means the inverting amplifier or the non-inverting amplifier. So what is the output voltage for the inverting amplifier? Formless. Output voltage for the minus V2 RF over R1. So V in voltage we have given, RF is as it is, with the RF, the R2 is connected, correct? So this is, we got it as so. So finally we need to calculate V naught, that would be 1 plus V01 we have calculated from this case, that is 1 R3 by R1 1 plus R2 minus RF by R2, correct? Now the last thing is, if suppose R1 is equal to R2 is equal to R3 is equal to RF, then in that case output voltage is how much? In this case they said 2 op-amps we have to use. Okay, so as you can see that it's a summing, so one of the op-amp will use summing amplifier, right? Another thing, as you know, the output voltage of the summing amplifier is V0 is equal to minus RF by R1 into V1. I am taking 1 minus RF by R2 into V minus RF by R3. So every time we need negative sign, correct? But they have given you the positive sign. So whenever we want to change the sign, for that we have inverting amplifier, correct? So basically in this we have to use two types of amplifier. First one is the summing amplifier and another one is the inverting amplifier. Okay, now tell me, any doubt up to here? No, they, we can add for V3, we can add for V4. Generally they'll give you for 3 voltage, not for 2. Okay, you can use 3 also, as I told you, the summing amplifier. Okay, then R3 then added, then it would be minus VA plus VB plus V. Okay, now see, can we write down this equation as, because we have to use only 2 op-amps they have mentioned. So V naught is equal to minus 6 minus of minus 1 plus 9V3. Can we write it down like this? It would be same, minus and minus, that would become plus, right? Minus 6V2 as it is Then 3V1 9V3 as it is. I put minus and minus. It would be same. Can we write down minus 6 minus? I'm considering this one as only this as a another variable, like we can denote it by v01. Okay, where I'm putting v01 is equal to minus of 3 1 plus 9 v3. Okay, so in this, now we if we'll see this equation, in this we have uh, two op-amps, right? So now we have to realize v01 using op-amp adder and v not as using another adder. Like suppose I'm giving, like in this we have to use adder, right? In the adder means where are providing the voltages, negative, positive one is always it. With the negative one always feedback resistance there, right? This one is v1, okay, and this one is okay, this one is r1, one is r3. Why I have taken this? Because as you can see v1 and v3 are added with each other, correct? Hmm? Now that's why I have taken v1 and v3. So its output is how much? v01. So v01 is according to how much? If I'll take it according to the formula, that is minus of rf by r1 into v1, right? Minus of rf by r3 into v3, correct? So rf they have already given, what they have given the equation minus of minus 3v1 minus 9v3. Up to here we have drawn. We have drawn minus 3v1 minus 9v3. Okay. If I'll compare this with this with this, then can we get the value for R1 and R3? Can I write down RF by R1 is equal to 3, right? इसकी जगह ये है V1 is there, then RF by R3 is 9. Can I write it down like this? And RF they have already mentioned in the question, that is 10 kilo ohm, correct? So if RF is 10 kilo ohm, R1 is how much? 10 by 3, that is 3.3. R3 is how much? 10 by 9, that is 1.11. Okay, yeah, it's kilo ohm na, so it would be 0.3 kilo ohm, it would be 1.11 kilo ohm, and RF is 10 kilo ohm. Okay, now tell me, any problem? But this is not our complete circuit. This is just we have drawn V01, correct? Now again solve it completely. We need to draw again the adder, right? Because it is the combination of V2 and V01, right? So if it is the combination of V01, so V01 will take another in. Again positive one is grounded, negative is connected with the feedback, and in this only we need to take the summing amplifier. So negative one of the output will become the input of the second, and another input is V2, right? और यहाँ पे भी एक और resistance will added, because if we'll have voltage then we'll add resistance. Its voltage is V01, then it's R01, voltage is V2, resistance is R2, and here the feedback resistance. Okay, so now what is R01? R01 is always equal to RF is 10 kilo ohm, correct? This is 10 kilo ohm, this is 10 kilo ohm. Well, now we need to calculate R2. Similarly, can we compare it? again it would be 10 by 6. Like ये 10 by 3 था, 10 by 9 था, that would be 10 by, and 10 by 6 much 1.67. So the final block diagram. You can write it down like this. So R2 is equal to F by 6. So what they said? They said that we have to use two amplifier, right? And we have used two summing amplifier. The most important one was one of the question you will definitely get in this of this kind in your exam. 100%. Sorry. So in this case, this V naught is equal to, as you can see, that negative is same that we want. Negative is same, that's what we want. We don't want the positive. So we'll connect V3 with the inverting amplifier. Okay. So we'll provide positive V3, then output would be V negative, negative V3. If I'll provide negative V3 in the summing and amplifier, then we'll get positive V3. Understood?